Hi, everyone. Welcome to day 2. I'm very excited. Definitely want to keep you up to date. So first off, a little bit about me. I'm Veronica. I'm a blockchain developer. I've been a blockchain developer for the last 3 years. I'm here today with Linum Labs. Linum Labs is a blockchain development house founded in 2016, mainly focusing on everything blockchain and Web3. They've done some incredible products from like small projects that are just POCs all the way through to like full production ready systems. Do everything from consultation, design, development, smart contracts, and decentralized applications. Yeah, I'm really excited to be giving this talk because I'm South African and I'm really passionate about the South African government and blockchain and its potential to really revolutionize the space and bring South Africa properly into the 21st century, into the digital age. So yeah, just some basic housekeeping. On, I think, this side, you should see the chat where everyone's talking. There's also a questions tab. So while I'm talking, if you have any questions, please put them in the questions tab. Today, after each section, we're going to stop and then answer the questions. So if you want, you can use the raise hand functionality, which is also a little button up there next to chat. And then I'll bring you onto stage. You can ask a question. We can even have a little debate. It'll be fun. Yeah, so there's also one last thing. There's little reactions at the bottom where you can just make little cute emojis, if it's not necessarily a question, but you just want to say hi. Yeah, so that's it in terms of housekeeping. I hope you guys all have fun. Cool, so today what we're going to be covering is just a brief recap of yesterday and then some really interesting government use cases. We're going to look at financial and payments, transparent fund distribution, healthcare and medical, vaccination tracking, and self-sovereign data ownership. Later, we're going to have a talk about agile governance, and then we're going to do a group brainstorming session. Cool, so just a basic recap of yesterday for anyone who maybe wasn't in the call yesterday. So just a basic understanding of how blockchains work. So pretty much there is one ledger that you can think of as like a massive spreadsheet with everyone's balances on it that's stored at multiple locations on multiple machines. These are called nodes that are running the application that stores this. In order for changes to happen to the spreadsheet ledger, you need to submit a transaction that has your requested changes. This needs to be signed by your private key. We're not going to talk about wallets just yet, but the wallet allows you to sign with your private key, which is like a mathematically verifiable way of saying you wanted this to happen because you signed it. You can think of it as like your bank account PIN, right? Because you use your PIN to kind of prove that it is you that's using your card. So that's how signing works. And then it needs to be verified by miners, which are just a type of node that stores the spreadsheet. Once the transactions have been verified, they get grouped into blocks, and then the ledger is updated with the block of changes. The reason it's put into blocks and not just each change happening all at once is because all these computers are all over the world, right? And they all have different internet access and different latencies and that kind of stuff. So the changes are chunked into blocks in order to ensure that all the nodes have the same changes at the same time. Yeah, so just some terminology, right? There's computer storing it on nodes. Changes are transactions. Miners are a type of node that approve and verify transactions. So they make sure that your signature is correct and it's real. They also verify transactions and create blocks. They get incentivized to create blocks. If a miner successfully creates and mines a block, simple spreadsheet, if you can think about it like that. So it doesn't actually allow for any more complicated changes than balance go up or balance go down. Whereas Ethereum, which is another blockchain, is a programmable blockchain, which means that those cells in the Excel spreadsheet can do really clever things. You can program them to run applications, right? And those are called decentralized application or dApps. Yeah, I think that's everything. But it's definitely a complicated thing. So if you didn't watch yesterday, I recommend going and watching it. It is on YouTube, on the Linum Labs YouTube. Cool. So we are going to jump into government use cases now. This is a continuation from yesterday. So just before we start, yesterday we discussed the importance of digital identities and digital electronic identities. So like an ID card on the blockchain, and how you can't really have any other blockchain use cases in government until you've got identity down. Because obviously, you know, if you don't have a proper signing mechanism, you couldn't say, for example, do voting on the blockchain, or any of the other use cases we're going to be discussing today all kind of require some level of electronic identity on the blockchain. Cool. So the first topic we're going to be covering is finances and payments, mostly focusing on central bank digital currencies. So what these are kind of blockchains that are created by central banks. So, you know, like SARB, for example, that then issue a digital currency of the country. These are not quite blockchains because they often have their own functionality, like being able to take taxes off and that kind of stuff, and as well as more privacy than public blockchains allow for. So they're blockchains, but they're their own category. Yeah. So CBDCs use blockchain-based tokens to represent the currency of a country. They act as secure digital instruments. So currently, not to get too much into it, but currently when banks issue loans or, you know, just your balance in the bank account, it's not necessarily that they have that much money, because banks can have fractional reserves of the actual amounts that they say they have. So a CBDC would be the equivalent to paper bills, right? It's a verifiable bit of money. Like there's no chance that if the bank goes bankrupt, that money is going to disappear, because it actually exists, right? It's not just the bank saying that they will pay you back for that money. They will also enable central banks to keep up with the digital world, which we will discuss a little bit later in more depth. Commercial bank use cases, like, for example, loans and that kind of stuff, they may decrease the ability of commercial banks to fund credit options, right? Because they can't have a proportional reserve anymore, because it is, depending on the design again, because they won't be able to have that proportional reserve, right? It'll have to be equal. They won't be able to offer as much loan and credits because they will have to actually have that money in the bank. There's also major privacy concerns, again, depending on how you design it. But, you know, it could be designed in such a way where the government can see all your transactions forever, and really have, you would have no privacy in some of the designs. But this can be circumvented in quite a few ways, one of which, the easiest of which, is just not attaching identity to payments. So, you know, I could make a payment to someone and it just wouldn't say who sent the money or who received the money. It would just say that a transaction happened. So in terms of global CBDs, we can't really discuss them without discussing like the recent catalyst that kind of made a whole bunch of governments actually look into the solution, which is Facebook's Libra Coin. So just to give you a quick background, Libra is a project that Facebook is desperately trying to launch and getting a lot of regulatory pushback on it, which would be a cryptocurrency that Facebook would run and manage that would allow people to make online payments on Facebook Marketplace, WhatsApp, Instagram, and all the other subsidiaries of Facebook. The reason this really rubbed some governments the wrong way is because there's major concerns about the sovereignty of nations. Obviously, currency control is something that nations really work on very strictly, you know, and they have lots of regulations around it. And having a digital currency like this could really hurt their ability to actually manage how much currency is going in and out of the country, which would affect their ability to actually manage the inflation rates and value of their own currency. As well as this, Facebook does not have the best track record with privacy or data ownership or generally looking after their users. So there's also major concerns around that, especially because in a lot of countries, Facebook is pretty much a replacement of the internet. So them introducing a currency into these developing nations could really, really hurt these developing nations' abilities to actually work. On top of that, Facebook could also just ban your account. And then if you have any money in it, it could just be lost, which is not really how currencies are meant to work. So there's major concerns around this. And it's really sparked quite a few countries to actually look into CBDCs quite seriously. So in terms of interest from other countries around CBDCs, there's quite a few countries that have already implemented a blockchain-based solution, not necessarily a CBDC though. So, Uruguay, the Bahamas, France did a pilot. Other countries that are looking at it, China is planning on launching their CBDC in the second half of this year. European Central Bank is looking at it quite closely, and Saudi Arabia and the United Arab Emirates are looking at doing a collaboration for interbank payments through a blockchain. Obviously, it's in the region. But yeah, so this is just an overview of countries that have been looking, researching, developing, and really going for CBDCs. You can see South Africa, we're in the development stage. We did Project Corker, but Saab is actually looking at quite a few solutions. Oh, sorry. Got to click off of it. So now it's just a use case study. I would love to look into China with you guys. So China has been making a lot of developments around CBDCs and a whole bunch of other payment solutions. So they would be making a blockchain-based service network, which is a step further than a CBDC. So it would be a permissioned blockchain for applications and tokens. Permissioned, of course, because it's not public. You need KYC to be, entered as a member of this blockchain. They also have further plans to create a universal digital payment network. So this would be, again, a step further than a CMBD. Than a central bank digital currency, because this would allow for payments across, interbank payments and all that kind of stuff would also happen on this layer. China already has a digital one, but it's not actually a CBDC because it's just a digital current. It's just a digital representation of the currency. It's not actually a CBDC. Like we spoke about earlier, where commercial banks can have reserve ratios. So with this digital yuan, they still can. So it is not actually a CBDC. So China is a very interesting use case because their banking system is quite advanced already. And on top of that, they have a massive demand for something like this. They have 92,000 transactions per second, sorry. And for comparison, South Africa has about 70,000 transactions a day. So it really gives you the scale of things. So they really needed this solution quite urgently, which is why it's happening so fast. On top of that, they were actually cited Libra's investigation in the US Constitutional Court as a reason for speeding up this development. But yeah, so they plan on having a base payment layer that does not face the public. The reason for this is because the infrastructure required to face the public for them, because of how many transactions they have, would not be sustainable. So their base payment solution would only face banks and larger applications like Alipay and that kind of stuff. And second of all, they don't want to step on the toes of commercial banks and replace functionality like that, because again, they wouldn't be able to handle the kind of volume that would require. Their blockchain is going to have smart contracts. So this is what we're talking about with programmable money, but they have severely limited the functionality of these smart contracts because they don't want it to detract from the fact that it's a digital currency, from its digital currency monetary role, as well as smart contracts might make the blockchain itself more valuable than they plan on or expect it to be, which would affect their currency's value. So again, it's all about monetary policy and actually managing the value of your currency. So China's privacy with this blockchain has been quite a big concern internationally. China's central bank hasn't been super clear on the level of privacy. They've said that they want to find a balance between anonymity and compliance, but many have speculated that there will be very little privacy, if any at all, from the government being able to view your transactions in quite a granular level. Despite this, China's CBDC efforts have been called like the most advanced initiative being developed globally. Obviously, they have such a huge demand for this kind of thing, they would need to really step up on that. Right, so before I get on to this next topic, I'm going to answer the questions. What are some of the potential functions in a smart contract? So for example, in Ethereum, right, the smart contracts are not limited. They can do pretty much anything. And applications that have been developed on them have mostly been focused around financial applications. Recently, we've seen a massive spike in scarcity, artificial scarcity on the blockchain. So for example, NFTs, which are non-fungible tokens, which means like one is not equal to the other, like artworks, you can't just interchange them. But an example of limited functionality might be that you could make an application that you pay it in one currency and it swaps it out for another currency, simple transactions where it's like a one-for-one kind of thing. So it would be quite limited functionality. Could China's digital yuan potentially replace the US dollar? Yes, it could, which is why there's been a lot of almost like an arms race to CBDCs, because it really could. The US dollar is also currently experiencing quite a large inflation jump because of how much currency they printed last year. I think it was almost like $2 or $3 trillion. So there's a real risk that it could replace the US dollar as the international reserve currency. Cool. Are there any other questions? You can also raise your hand if you'd like to be brought onto stage to ask your questions. I'm assuming that in the short term, CBDCs exist in parallel to fiat. So from my understanding, it again depends on the implementation. So I think in China, they already cash is used so little that it's practically not really a consideration there. So for them, I think it would be a straight up replacement of fiat currencies. I do think in countries like, so for example, South Africa, where we do use cash quite a bit, it's a much larger percentage of our daily transactions. It would be run in parallel, right? So it would really just be a replacement so that instead of the banks having those promissory notes, it would be an actual cash equivalent balance. All right, cool. I think if that's all the questions, I'm going to move on to transparent fund distribution, which is a fun one. So blockchain could be used to distribute funds in quite a transparent way. This could really, really help South Africa. We have quite a large irregular spending issue, especially on the municipal level. So a whole bunch of, I think all of the South African municipalities were audited, and 93% of irregular spending went to these three topics. So these three topics are procurement without following competitive bidding or quotation processes, compliance with procurement processes, and inadequate contract management. And this has cost South Africa quite a large amount of money. So blockchain could counteract these non-compliance through programmatic means. So what I mean by this is if we had a blockchain that was built by South Africa for South Africa, right? It's context specific, that would allow us to do the procurement process on the blockchain. What it would enable is just a massive increase in transparency, right? If you, for example, wanted to do a tender process on the blockchain, right? You would put your application up. What are you looking for? What service or goods are you looking for as a government entity? People would be able to bid or apply for it publicly. And then whoever gets chosen, right, this will all be public. So there'll be this kind of traceable history of what happened and who signed off on what. Because again, we were talking about signatures and how important they are, right? So we could have that kind of system where we could see granular transactions, who did what, when did they do this, who signed off on it, which would really increase transparency and accountability, as well as just general trust in the government process, because people could actually go check it. If they're suspicious or they want to know what's happening, they themselves could go look and see what is happening. It would also significantly reduce the amount of effort required to do an audit, because all the information is on the same blockchain, on the same time spectrum. So it'd be much easier for audits and general like quality assurance. Right, so this is what I was talking about now. So you would have your blockchain, right? And then requests for resources and services would be put on the blockchain. So there'd be like a request form on the blockchain saying, this is what we're looking for. Here's the specifications. Government departments who need it would be able to put these requests in. Public watchdogs can observe the entire process and look at it after the fact. And potential service providers and resource providers can apply through the blockchain. This also might have the side benefit of increasing the visibility of these tenders and what is actually available for providers to provide the government with in terms of services. So before we move on to SASSA, are there any questions? Great, okay. So SASSA is a great example of where transparent payments and blockchain technology could really, really help South Africa as a whole. So SASSA is the South African Social Services Association, I think. I might have got that wrong. But SASSA was really pushed to the brink last year with COVID-19 hitting South Africa as hard as it did, with the just influx of people who required and actually needed to apply to receive SASSA payments and Social Security payments. And there were major delays in payments. And there were also quite big scandals of in the department itself. So SASSA could really benefit from blockchain in quite a few ways. So first of all, one of the major issues with SASSA is duplicate entries, right? So someone applies for a grant and then they apply for it again, and then there's 2 entries and they get paid twice. And this costs South Africa 2 billion rand a year, which is an insane amount of money to lose to duplicate entries. So this would easily be discovered with blockchain. It could literally, depending on design, as always, you could design it in such a way that when you upload someone's payment or someone's details, right, it goes and checks if they already have that person for that payment, and would be able to just cancel it out on registration. Be like, no, you've already registered. You're already a recipient of this grant. You don't get it twice. Thanks for coming. Also, obviously privacy would be a major concern with this. This is not information that should be public or should be publicly readable. So it would require quite a bit of privacy engineering, right? So hashes could be used, which is just a clever programming mathematical thing that pretty much makes, you can put information into it and it'll give you like an ID that you can't work backwards to the original information. So it's just like a little ID number for that information that you can't figure it out backwards. So, you could use that to store the person's name and their ID number. And that way, next time they upload it, you can go and check. We already have you. You're already receiving this grant. It's okay. We're not allowing this duplicate entry. Yeah, are there any questions? Okay. One of the advantages of blockchain is the decentralization of the system. With CBDCs, will it still be decentralized? That is actually a great question. So again, you guys are going to hate me for this, but it depends on design. So for example, the Chinese CBDC would be decentralized because all of the banks throughout China would be running a node for it. So it would technically be geographically distributed. But obviously there would be KYC to become a node. Like not everyone could become a node, so it wouldn't be like fully decentralized. And chances are China won't allow anyone outside of China to become a node, although they might. So yeah, it depends on design of the system, but most of the time, most central banks will allow the banks of that specific country to participate as a node. So technically it is distributed. I hope that answered your question. All right, cool. Any other questions? All right, lovely. Cool. So now we're going into what about security? Okay, so I'll answer that quickly. So I'm assuming you're meaning what about security with SASSA, not with CBDCs. But you can raise your hand if you want to be brought onto stage to ask your question. Yes. Yes to CBDCs or yes to... So, okay, hold on. So in terms of security, right, blockchains are significantly more secure than traditional systems because of the way they're designed, because there's this, everyone keeps a storage, a copy of it, right? And they all get updated by the same blocks. And the fact that every single change is, through transactions, is verified by a miner and made sure that the signature is correct. That the transaction details are correct. You didn't send money that you didn't have and that kind of stuff, right? They're verified. So they tend to be quite a bit more secure. They also help with cybersecurity, which we spoke about yesterday. So they do tend to be some more secure. Another advantage of SASSA would be the distribution of payments, right? You could very easily just put a lump sum into the blockchain and tell it, hey, distribute this to all the grant recipients, which grant recipients receive how much, and then it could just distribute them all at once, which would greatly help with the delayed payments and the issues around that, because you could just send it directly to the SASSA cards from the blockchain, depending on setup. So that's about security. So there's a follow-up question. Can permissioned blockchains be a better solution for the states because there's more control and design? So most governments, when they're looking at blockchain solutions, are looking at permissioned blockchains almost exclusively. So the reason for this is that permissionless blockchains, anyone can join, anyone can be a node, and there's no kind of central authority, right? So for example, your wallet, your public-private key pair got stolen and someone stole all your money. There is no central entity to be like, oh, sorry, we'll undo that. It just won't happen. Your money will just be gone forever. And that doesn't really work in a government use case. Can you imagine if someone's identity got stolen and it's like, oh, well, they stole your identity. Sorry, you're just going to have to come up with a new one. That's not an acceptable solution. So all government blockchains are at some level permissioned in order to ensure that they can do things like undo a transaction, issue new identities, issue new wallets, that kind of stuff. So it would have to be a permissioned blockchain. And you do need that level of design control in the permissioned blockchain. Another question, could people not create alternative or duplicate digital IDs? So we spoke about this more yesterday, but to just touch on it briefly, there's two types of digital identities, right? There's a digital identity and then an electronic identity. So an electronic identity is a digital representation of a government issued identity, right? So this would be like your ID number and your fingerprints, right? So an electronic identity, there can only be one of, and the government would then need to ensure that there is only one of those. Whereas a digital identity is more of like a digital representation of a context of you online, right? So a digital identity would maybe be all of your social media profiles are linked to the same digital identity. And then your tax account and your business account for payments and that kind of stuff are attached to the same digital identity. And then you can have all these multiple digital identities explaining these different contexts that are all then linked to the same electronic identity that you wouldn't necessarily need to reveal on the digital identity. So those are the two separate layers. If somehow in a government's blockchain there was a way to have duplicate electronic identities, you would have a big problem. But again, like with the SASSA payments where we're talking about duplicate entries, you could prevent them from even making their way onto the blockchain. Someone would try upload one with the same ID number and it would be like, we already have one with this ID number, that's invalid. Yeah. Another question, are there any live examples of blockchains being used? So yes, there are. So for example, China's going to be implementing it in 2021. Hold on, let me actually just go back to that slide. So where is it? Right. So here we can see, right? So Brazil has already launched a CBDC, which is a form of blockchain. Yeah, I don't think this is necessarily up to date with current times, but yeah, like Uruguay, Bahamas, France, there's quite a few examples of blockchains being used. On top of that, for decentralized blockchains, there are hundreds of decentralized blockchains that are actively in use right now. There's also quite a few that are trying to scale, so be able to handle a lot of transactions at once in order to accommodate the growing demand for blockchains. So yeah, there's definitely live examples of blockchains being used. No stress. How long would it take to build such a system and the cost? So I'm not sure if you're talking to SASSA specifically or like the whole blockchain. Do you want to actually come on stage quick? If you raise your hand, I'll bring you on stage and you can, yes, SASSA, okay. So for SASSA, for example, it would, any system like this would be a large infrastructural investment into the digitization of South Africa, right? So for a project like SASSA, just off the top of my head, obviously I'm not a member of SASSA, I don't fully understand how the system works, and I don't have that kind of level of detail and oversight I would need to be able to fully scope this. But you're probably looking at between 2 and 5 years with a dev team of probably between like 30 and 60 developers. Like you're looking at quite the team, and they would need to be quite specialized people. So in terms of cost, though, I wouldn't be able to estimate that without more information. But I hope that gives you a good starting point. All right, cool. So we're just going to take like a 5-minute break quickly and get our guest speaker ready. And then we will be right back. So you guys can just hop back into the tables and we will be.
Hello. Am I ready to call or?
All right, lovely. So here's our guest speaker who's going to give us a lovely discussion, talk about agile governance. So take it away.
All right. I'm still trying to figure out how to control this, but perhaps maybe I'll just go ahead. I'm not sure if everybody can see the screen and can hear me well. So what I'm going to talk to you about today is more on the agile regulation for the fourth industrial revolution. Now, my understanding here was that we'll be talking to the people who are from the government. So the focus is geared towards the audience from the government. So what I want to basically do, it's basically, before I go into the description of the agile, to just give you a slight overview on the Center for the Fourth Industrial Revolution. More starting from the network and getting into the South Africa situation. Basically, we have what is called the Center for the Fourth Industrial Revolution, which is dedicated to co-designing policy framework and governance protocols. And those government protocols, we highlight that they include, it can be laws, it can be regulations, it can be norms, it can also be just best practices that will accelerate the application of science and technology. So you're talking about blockchain today, and blockchain could be one of those emerging technologies that could benefit from such work. Now, the network itself, and I'll talk about two things where I'll talk about the network and the affiliate center. The network is the whole structure that serves as a platform to convene key stakeholders to work on the ethics, values, and the regulations of the fourth industrial revolution. Now, the government partners will then host and advance the development and the deployment of the pilot frameworks. So the idea is that we bring everybody together, we co-design a framework, and the government as a partner will then host and support that. And that's the key part of the agile method. And what does happen is that the government can do that through secondments of representatives to the centers, which will then enable the centers to work together with the secondments through those. They are called fellows that you can have in the in the network. So the free footprint is that the forum, and the forum here means the World Economic Forum, has centers in China, India, and Japan, and the US. Now, the forum there manages those centers. So those are called welfare C4IR centers. Then you do have the affiliate centers, which are managed locally in each country. In South Africa, we are one of those countries that have our own center, and it has to be clear that this is our own center. The agenda there is set by us as South Africa, and we just are affiliated to the whole network, and we work with the whole network to achieve the work that we do. So having just introduced you briefly to that, the discussion around the agile regulatory system is basically based on on two aspects. One of the aspects is the fact that the time it takes for the development of these technologies, it's actually much faster than in the previous, in the previous industrial revolutions. So what does happen is that you tend to find that the pace at which it develops, the regulatory system doesn't catch up to that. We then had this method, but we came up with that enables the interaction between the innovators and the government at a very early stage, so that we can begin to identify where the gaps are in the regulation and begin to work through the regulation, through a process where you then prototype a regulation and then you test the regulation before you can scale it up, as opposed to the standard waterfall model where you go through the process of developing the regulation and only promulgate it afterwards, and sometimes find that it is anti-innovation once you have put it in there and you have to restart the process of redesigning the policy again. So it does benefit both the businesses, in that you can be able to introduce novel products a bit earlier, and you can introduce them during the period that you are still testing the policy, whereas the government will then enable the innovation to come in a bit early and attract the investment in the country a bit earlier than we would. We can have many examples in terms of where we are behind in terms of introducing new regulations. As a good example, when we're talking about the 4G networks, we were quite late, and we are actually at this particular point only dealing with the spectrum allocation for that now, when actually the 5G is already in place and most people are focusing on releasing spectrum for 5G. So it's those kind of things that we can be able to do a bit earlier if you work together in an agile manner. Now I want to just maybe take a step a little bit to say, in terms of the regulations, what does that mean? Because sometimes there's a different understanding of what that means. Now you see that picture there is is a publication that was done by the World Economic Forum in December 2020, which is a toolkit for regulators, and it talks about the agile regulation for the fourth industrial revolution. Now I can actually work with you in terms of going through that particular toolkit and see how the governments can be able to do that. So in that publication, it's clear that what we are talking about here when we talk about regulation, we refer to generally the mechanism by which government sets requirements on businesses. And the regulator then will refer to either a person or authority who develops or administers the regulation. So this may, in fact, mean in many cases the government itself is a regulator, where the government then sets the regulation and the mechanism for business. You can take the taxi or whatever part of the transport system you're talking about. What you do find is that the provincial governments are the ones who set the regulations, the requirements for those businesses, and therefore the provincial departments are regulators in that particular service. So then this again, it will include everything from laws, formal and informal orders or rules or administrative formalities. It could also include self-regulation by the bodies that are allowed to do so. So we do know that the government, the major reason why governments regulate business is to be able to deliver better outcomes for the economy, society, and the environment. One of the examples would be to safeguard citizens' privacy, and government will establish a regulator to be able to do that particular service. So having said that, I guess one of the things that we could just highlight is what, in a sense, we have seen with the COVID-19 pandemic come in. It then end up enabling a little bit agility and flexibility in what we do. One of the good examples that has been brought by this, and I'll go back to the telecommunications example again, is the fact that once the pandemic came in, it became clearer to the regulator, spectrum regulator, that the networks are being choked. There is no longer any capacity there. And the regulator had to quickly release the spectrum for the players to start implementing the networks. Whilst it was a temporary thing, but it has in actual fact, that particular process has fast-tracked the process of releasing the spectrum, because currently you do have the networks that are running on that particular spectrum, and it's clear that there's no longer going back in terms of not releasing that spectrum for the networks to work. So this can be applied in many other areas, but you could see that with the COVID-19 pandemic being declared across the world, it has actually accelerated the agility in the regulation. I've covered this in a sense that the C4R network projects that we have, they do support the government to adopt a more agile regulatory approach. I think when you look at this issue, I've talked about the pacing problem, and the pacing problem basically is where you struggle to keep up with the development in the technologies. But then there's another problem that would be solved by the agile approach. It's more of a coordination problem, right? Where now you are struggling to respond to innovation in a joined-up way, as they frequently cut across those administrative and sectoral boundaries. So the method looks at how do you coordinate the regulation system across different regulators, the public sector, and so on. So the first thing that you do in the project is to be able to identify who gets impacted by the regulator, and then you follow by the regulation that you want to follow. Then you follow the method where you then say you are looking at an organizational level, the whole of government level. First, you do a self-assessment of the key weaknesses and strength of the regulatory approach that you are following. So we take blockchain, for instance, and if you want to apply blockchain in terms of self-sovereign identity, we may want to say, then we come in and check. We do complete self-assessment of the weakness and strengths of our regulatory approach. And then before going into a normal mode that we go into, we then get the business insight. We can actually get the business insight by creating some kind of a regulatory sandbox where you don't just get the feedback, but you then go out and ask the businesses to test the regulation. So you come up with some kind of regulation, and then you test that with the businesses to say, how will what I want to do benefit the innovation that you want to do, right? So it's not done as government people sitting together on their own, but it also has the business inside in a way. And then once the results have come through that particular process where there has been the testing with specific innovations, you then can take that to the peer review, where it gets reviewed by other regulators, other governments, of course, with the World Economic Forum or others, where then you take those results and then can then form the, the essence of how you then reform the system. So you bring in the innovation, you test it, and it sees that you see the benefits. Then only then you say, okay, so this is how I will reform that. And that peer review report is then given to government on how to reform that. What happens is that because this is a network across the world, you may find that in some cases other governments have done that, and you have seen the benefit of that. So it might take shorter for us by learning from the others within the network and be able to, and using the guideline that we have from others to enable better regulations in our side. So the center that we have now that we are hosting at the CSIR is adopting this agile methodology, where we will bring everybody in together to work on the regulations. Now, this has been, in a sense, initially tested. As I said, you have sometimes you test it with one government. The first thing was done for the UK Department of Transport, which was then piloted in the UK in 2020, at the beginning of 2020. And then there were further pilots done in 2 countries, in Japan and in UAE. With that, then it's almost ready now, the agile methods to be rolled out across to many different areas. And we are in a position where we can be able to learn from those. As I said, we have now a toolkit that will guide us in terms of looking at that, which has been published in 2020, that I can make available to the partners in that. So this is in a general where we are. So there's some requirements that we may need to have, and these are generally the requirements that we have for a project. But it's more of the capacity that we are building in order to be able to serve the government in dealing with the agility in the regulation system. Yeah, as once again, we have the ability to tap into the wide network. There's what is called the Global Future Council on Agile Governance, which would always get the experts in, and we can send in the experts from our own team here in South Africa to be part of that, to come up with a more cohesive guidelines on doing the agile governance. This is what I had for you folks today. Thanks.
Thank you so much. That was great. Are there any questions? Someone said thanks. Not a question, but welcome nonetheless. Cool. I'm going to stop your screen sharing now.
Okay.
All right, great. Thanks so much. And yeah, I'll see you in the tables after this.
Okay.
Okay, great. So I'm going to start sharing my screen again, and I'm going to pick up where we left off, which is getting into the health and medical use cases. Give it a hot second to load. Okay, so specifically, blockchain is really good for supply chain use cases, right? Anywhere where you need to have like historical data that you can go and check and verify and see who approved this, who let this happen, and that kind of level of detail. So it's really good for supply chain use cases. And one of the most important supply chain use cases we have is in the medical sector. So we're going to look at the following 3 use cases within the medical sector. So supply chain tracking and management for counterfeit medication and medical devices, because that's actually quite a big problem in Africa as a whole. Longevity in medical records and verifying medical practitioners. So to just jump straight into the supply chain management, right? 42% of detected false pharmaceutical products occurred in the continent of Africa. That is a really large percentage of all fraudulent pharmaceuticals, right? And currently, it's nearly impossible for a South African citizen to verify if their medication contains the active ingredients it claims to, right? Testing of medical of pharmaceuticals is really expensive for an individual to go and get their medicine actually tested, right? So allowing for a blockchain proof of provenance system would really help not only patients, but also doctors and hospitals to verify that the medication is in fact what it says it is, and that there is proof of it going all the way back from, the supplier to the patient. So the use of barcode. So in South Africa, just as a pretense before we get into this, South Africa's supply chain for medicine doesn't rely on barcodes. So most medicine in South Africa doesn't actually have a barcode. And if it does, the barcode is not actually used for supply chain management. In South Africa, we use batch numbers and expiry dates, which is really problematic because it is actually quite easy to make a counterfeit batch number, especially if you have access to genuine medication. You can even make sure it's in the same series of it. So it's really difficult to verify that this medication is in fact fake. And yeah, an expiry date's obviously not a great metric to see if something's real. So this is our first problem. And the second issue is that a lot of hospitals don't actually have the facilities necessary to be able to verify with QR codes or barcodes that the medicine is real. And this has become specifically a major issue now that we have the COVID vaccine distribution. So yeah, the use of barcodes at any stage during the vaccination program would be an exception to the norm, as medicines generally are not barcoded in South Africa. So a trustless blockchain could really help with the tracking of medication and medical devices from their manufacturer to the patient who needs it. And this is specifically important in Africa, where we have such a large percentage of medicines being fraudulent, and like a medically illiterate population, as most populations are, that can't actually verify the medicine themselves. And this is majorly problematic. And now with COVID, it's even bigger, but we will get specifically to vaccine tracking in a little bit. So hospital staff, nurses, and doctors as a way around this, right? Instead of relying on computer systems where you would require a barcode scanner, for example, we can use QR codes. 80% of South Africans have a smartphone now, so QR codes are actually more accessible than barcodes. So in a hospital setting, what we could do is create this supply chain management blockchain specifically for medical equipment and pharmaceuticals, where hospital staff and nurses could actually scan the QR code on the medicine or device and see its provenance, be able to see from manufacturer when it was shipped, who shipped it, where did it get shipped to, which countries did it pass through while it was being shipped, and where did it end up. And patients as well as clinics could very easily verify the status of this medication through this blockchain system with these QR codes. And this system, this is what we were talking about yesterday when I was discussing like leapfrogging, because we haven't implemented a barcode solution, so we can just skip straight to a QR code solution, which is, more efficient. Sorry, I'm rushing a little bit because we actually might run out of time before I get to finish all of this. So the next really important use case of blockchain in the medical field is longevical records. So medical identity theft and fraudulent medical providers is quite a big problem in South Africa as well. Patients can't easily access their medical records. Every doctor has their own little paper file with all your records in it and every test they've done on you. And if you move and you go to a different doctor, now you have a different file and it's not necessarily the same information. On top of that, if a medical practice closes down, now you just cannot access this file because it's a physical file that you need to go into the office and get. And that's not really acceptable in the 21st century. And this specifically disadvantages the elderly and those with rare or chronic medical conditions. If you get taken to a hospital and you're unconscious and they need to perform surgery on you, they really need to be able to access, are you on blood thinners? What medications are you on? Do you have any underlying conditions that they need to know about? So a system like this that would enable the longevical storage of medical records against an EID, like we were talking about earlier, would really be beneficial and could have a measurable impact on like the number of lives saved through just having that information when it's needed. So longevical medical record system could work quite similar to the medical tracking system. So you would have the blockchain that is created by the government for this use case, where medical records could be stored against an EID. Obviously, in the medical sector, as in all sectors, there are major privacy concerns. This should not be publicly accessible data. It's quite sensitive personal information. So it would need to be well encrypted, but also needs to be accessible to medical practitioners in emergency situations. So what you could have is a kind of hybrid system where in most cases, a patient would need to give a doctor permission to be able to access their medical records. And then you could have further segmentation of only being able to access like segments of your medical record that is important to the doctor. Your birth certificate's not relevant if you're going for a checkup, but your medical history would be. So the system would allow for patients be a history that this doctor accessed your medical records, and once you're conscious again, was this, good or was this fraudulent? So yeah, it could be a very powerful system that would enable a longevical history of your medical records. Oh, one more thing. On top of that, on top of just your medical history and that kind of stuff, you could have e-prescriptions. So a doctor would be able to prescribe you medication to your digital identity on the blockchain. And then you would just need to go to a pharmacy with your ID. It wouldn't require you to carry around that little piece of paper with your prescription on and hope that the pharmacist can read the doctor's handwriting. It would be a digital record, which would also, again, help in those emergency situations of like, what medicines are you on? Then the next thing is verifying practitioners, right? So there's in South Africa specifically now during COVID, there's been a lot of cases of nurses who are not qualified to work in an ICU being put in an ICU due to workers shortages and skilled labor shortages. And that can be quite dangerous. If you're not trained to handle ICU equipment or putting someone on a ventilator or those kind of really specialized procedures, people could die, and people have died. So being able to verify medical practitioners, like what are they qualified for? Have they kept their license up to date and that kind of stuff would also be really beneficial to the medical sector in South Africa. Especially now as we're getting into the real heart of the pandemic, where the vaccines are actually starting to get distributed, it's going to become essential for individuals on the ground, like actual people getting the vaccine from doctors, to be able to verify that A, the doctor is a qualified doctor, and B, the vaccine is a real vaccine. And, again, because we don't have a lot of these legacy systems, we can just leapfrog into a blockchain solution that is agile and flexible and allows for this while maintaining data privacy. So, right, so this kind of very naturally falls into vaccine tracking, right? So South Africa has already encountered some fake vaccine scandals. So Interpol seized, I think it was 2,300 vaccine doses just outside of Johannesburg. And, that's terrifying. They're already here. It's a major issue in China, but they are really trying to crack down on these fake vaccines, as they've already gotten a bit of a bad name from this pandemic, and they don't want to further worsen that with these fake vaccines that will actually harm people, right? Because we don't know what's in them. It's just a clear fluid you're injecting into your body. It's not a good idea. Interpol has actually issued an orange notice worldwide, warning countries to prepare for organized crime targeting COVID-19 vaccines, which is terrifying. And if not a real wake-up sign that we need to implement a system that allows us to verify vaccinations with more than just their batch number and their expiry date. So it's going to become so much more important as we get further and further into this pandemic, and as we try to get out of this pandemic, that there maintains a trust in the public health system. Because if people start getting fake vaccines and dying from these fake vaccines that have heaven knows what in them, that's going to harm, first of all, vaccines which are already on shaky legs in the public eye, and the trust in the medical sector. And we, as South Africa, cannot afford to have people not trust in the public health infrastructure. So the use of blockchain specifically could really help with preventing fraudulent vaccines. Even if we don't necessarily implement blockchain for longevity medical records and verification of practitioners, just implementing it as a tracing system, as a supply chain system for vaccinations using QR codes or even barcodes would just really, really help during this time. And it would also allow for transparency, which could disincentivize VIP vaccinations, which has been a major problem, not necessarily here, but in other countries. They've had issues of people cutting queues, bribery with medical practitioners to get the vaccine first and that kind of stuff, which is also, not really acceptable. If doctors and nurses need to get vaccinated first, just because you're some celebrity who thinks you're really important does not mean you should be able to skip that kind of priority queue, right? Especially not because most of them are partying. So the UK has actually, only 2 hospitals have actually implemented a blockchain tracking system for COVID-19 vaccines. Specifically because they are using the vaccine that needs to be stored at ridiculous temperatures. So they need to be able to prove from production to injection that this vaccine was actually stored at the correct temperatures. Otherwise, it's not going to do anything, So they're using blockchain technology and IoT devices, so Internet of Things devices, which is just, a thermometer connected to Wi-Fi. To actually make sure that the fridge temperatures were correct the entire time, have a little thermostat in the box of vials, and you can then verify, from start to finish that it was kept at negative to 70 degrees Celsius, and that it hasn't been denatured because it lost temperature. So we make sure that the data is accurate at the source, and after the point, we can verify that it's never been changed and it's never been tampered with, which is really important with the vaccine. There haven't been additional vaccines introduced into this batch. There was only meant to be 100, and now it's 110. So it's very important. And also being able to verify each of the individual vials as, QR codes. This was the one that the manufacturer produced, because often with these counterfeit vaccines and counterfeit medication in general, they're often mixed among genuine medication. So it's important to be able to distinguish on a very granular level whether or not it's a real vaccine or a real medication. So before we move into the next one, are there any questions? All right. So yeah, the health and medical sector really has some vital use cases that we could really benefit from implementing, even if it's just the COVID vaccine for now. Yeah. So the next topic we're moving on to is self-sovereign data ownership. So we kind of touched on this yesterday, and I will reemphasize again that you can't really have these, specifically this digitization of a service and protection without a proper e-identity, right? Like an actual e-identity. Specifically in the case of self-sovereign data ownership, it's actually vital that it's not just an e-identity tied to one government, but it's like a human identity tied to, say, your biometrics or an eye scan or something like that, where it can be internationally recognized and internationally verified, right? Like if you're in an airport, they should be able to verify that it's you through your biometrics. So with self-sovereign data ownership, it needs to be globally recognized because data travels globally. Data very rarely stays in one country. You know, if you watch a video on YouTube, it might be coming from 3 different countries before it actually gets to you. So it's really important that this is kind of a global approach and a global initiative that we take to make self-sovereign data ownership actually happen. And this comes with the very unique issue of how to maintain security and confidentiality in this information, especially with different countries having different ideas of what is private data and what is data that the government should easily be able to access. So this system, having a self-sovereign data ownership system, would also enable greater economic inclusion and also actually assists in refugee resettlement and AIDS. Because oftentimes with specifically refugee resettlements, their government often, if it's been like a minority, a religious minority that's been excluded from the country, they don't actually have a government issued ID. So an ID where they could actually own their own ID through biometrics is super important. And obviously with the inclusion of greater economics, the greater economics inclusion, comes from people being able to own their own data. And that data is super valuable. Data has been called, the oil of the 21st century. So if you're able to own your own data and actually be able to reap the benefits of people mining your data and making profits off of your data, it could really help people who, we never really had access to that kind of money that was being created by our data. And it's only right that we have access to it. It's our data at the end of the day. So the ability to identify people irrespective of their physical location is a really important first step towards true data ownership. And once a system like this has been established, of a digital identity that's verifiable over all the different steps, it's just a logical next step. So yeah, as I was saying, it would require international cooperation, and yeah, it would be really essential that countries could come together and agree on what is considered private information and what is considered information that the government can access and what is considered public information, and to make those really well-defined and clear and have all the countries agree to that. Like, for example, we were talking about the China CDPC earlier, and if they have access to all the transactional data, they might want a different level of access, and it needs to be universal and it needs to be universally agreed upon. So, are there any questions before we move on to the brainstorming session? All right, great. So, for our brainstorming session, we're going to break back into the tables room. And ideally, you're going to break into groups. There's going to be 45 minutes of brainstorming and then 3 to 5 minutes to present. We finished 10 minutes early, so we can maybe push it to like 6 or 7 minutes each. So I'm going to come around to all the tables after you've been discussing for a little while, and then give your table like a name over the use case you're discussing. And then ideally, only one person from your group comes and presents. But if there's more than one of you, we can make a plan and make it work. So someone asked a question. So before I move on to this, how close is South Africa to implementing any blockchain solution in any system? So SARB has already done Project Corker, which is a clearinghouse blockchain solution. And we've already run 2 versions of it, and it's gone really well. So we're actually a bit closer than you'd think. But again, it depends on each sector and each government branch. So yeah, any other questions before we break out into the brainstorming? All right, great. I am so excited to see what you guys come up with. So really, the topics are quite open. So anything, any idea you can come up with in the blockchain space that kind of makes sense for government use case is an A-OK idea. I'll give you guys a good 5 to 10 minutes before I actually come around and give all the tables labels. So yeah, good luck, and I'm very excited. Hello, everyone. So I think it'd be best if we start this now because both groups have actually a lot of really good ideas. And I think once everyone's presented, we can kind of have open floor discussions around some of these ideas because I think it would be really beneficial because there's a lot of really good ideas going on. So to switch things up, we're going to start with group 2. So whoever wants to present for group 2, it can be multiple people. If you just say so in the chat and then raise your hand and I will bring you on stage and you can present. Lovely. All right.
Hi, good morning. I'm not sure which group I was in, so I just raised my hand.
You were in group 2.
Okay, right. So lucky gamble
Perfect.
there.
Yeah.
Yeah, so I had a few members in the group. So obviously these are not all my ideas, and the members can also add points. So I think to summarize our conversation, Medal spoke about potentially doing a proof of concept. And so the value for a proof of concept is to show that a system is better than an existing system. So there was a little bit of a conversation around what it is that citizens need and how we can improve their user experience. But also because blockchain is a new technology, we would need to show the benefits of the blockchain over existing systems and existing incumbents in the space. So the value propositions for the blockchain are that it's decentralized, so there's no single owner, it's immutable, which means that it can't be changed or changes are tracked. There's security because it's a decentralized network, so denial of service attacks are much harder to do. So in looking at those benefits, what could it be applied to in the government space? So the first one we spoke about, because it's on all of our minds, is COVID. So tracking of the vaccine, which I think was an example that was spoke about, but specifically also the group spoke about long COVID. So we know that people might have had COVID, and then what are the effects in the short, medium to long term? How can a blockchain track people that have had COVID and what their medical state is over time in terms of fatigue, in terms of mental issues, those kind of things. So that's one. We have a few more. Another one is the South African Police Service. So currently, many police stations still have paper dockets, and depending on who you know, criminals can make these dockets disappear. So if there was some kind of blockchain system where the docket is added to a blockchain where it can't be tampered with or deleted, and then the next item actually is combined, but it's about provision of service and product to citizens. So the expanded public works program, which is a program where people are given some work to do for payment, and then there's the housing at for RTP homes. So in both of those scenarios, those assignments sometimes fall on people who aren't ethical, and so they are open knock someone off a list and put a person in place because they've taken a bribe, and so now they've bumped that person up the queue. And then Bongani in our team actually brought up a very interesting conversation. It's not specifically a use case, but it's a conversation around what is the private sector doing in the blockchain space, and is there potential to work with them on a proof of concept that they are doing, and it kind of aligns with what government's trying to achieve. And his point was, we are SA Inc. We are one nation, so there shouldn't be this siloing of what the private sector is trying to achieve with blockchain compared to what the public sector is trying to achieve with blockchain, and we can leverage each other, as we've seen in a number of PPP projects over the last few years. And then we have a colleague from health as well that merged a point made by Zubair from Parliament, which was around queuing systems and booking systems. So we know that that's a massive pain point for most of our citizens. It's so unfortunate hearing about really old grandmothers that have to be up at 3 a.m. in the morning to travel to sit outside a hospital in the early hours of the morning. So could we not have systems where that person has a particular time that they come through, someone is ready to assist them, and it's on a blockchain, so the slot can't be moved. But more importantly is the retrieval of that patient's information. So one of the problems, again, in these paper-based systems is that when they get to the front of the queue after probably sitting there for 5 or 6 hours, the person behind the counter says, wait, I've got to find your file, and they struggle to find this file. So is there not a way we could, and I know that there have been attempts to digitize these systems. We know that those programs exist, but again, centralized systems, sometimes on a slow network, and how many times have we heard the system is offline? So on a blockchain, because there are a number of systems, a number of computers that have the information, the likelihood of the system being offline is much lower. So putting patient information on a blockchain would mean that those kind of things can be accessed more easily than a single server, that when that thing goes offline, it knocks the whole country offline, which happens with banks. Okay, but that's us. Anyone from the group can also add. Thanks.
Thank you so much. Yeah, I think it's going to be really interesting to see where the crossovers are between the two groups. So if the speaker for group 2 could raise their hand, I will bring you to the stage. But yeah, just because I was obviously in both tables, I think there are a few use cases that actually have crossover, but we will discuss these after we're done with group 1. Otherwise, if you just say who you are in the chat, I will also bring you in. Is the speaker from group 1 still here? Okay, lovely. Good to see you.
Oh, I thought I'm
welcome to the stage.
Thanks. Am I audible?
Yeah, you're audible. We can hear you.
Okay, thanks, colleagues. My name is Kaiser. I'm from Group 1. We discussed few applications or benefits of blockchain that we can appreciate. The technology itself with its benefits being tamper-proof, transparent and trustless system. So we can use it to enhance existing systems. And we looked at the Department of Home Affairs, where we said we can look at SADC monitoring as people move around the region. Perhaps we can look at the application of blockchain tech to facilitate that and assist in terms of encouraging multilateral agreements, cooperation in SADC, and still at the same breath assist to monitor human trafficking in the area or in the region. That was one example. And then we also look at Department of Trade and Trade, Industry and Competition, where we could perhaps deploy blockchain technology to enhance their business licenses applications. Another example, Department of Transport. We're looking at a driver's license. Yes, they're using Inatis, but it looks like the system itself is not centralized. So perhaps we can use a blockchain tech to centralize the driver's license systems. And we looked at information sharing. This was in particular Department of Basic Education, where schools can be linked and enhanced the level of teaching. At the moment, we know they're using TV a lot, but I mean, we were hoping that we can also use blockchain to share. I mean, there are systems that are out there, but blockchain can also enhance those missing applications or solutions where systems are currently running. And then the last one, as an example, was a digital identity, where you can have your identity in your cell phone. But now there's a concern for security. If you lose your cell phone, what will happen? So those are the examples of applications that we thought of as a group. And then I'll ask my team to qualify me where I happen to bypass something. Thank you.
Thanks so much.
I hope I was audible enough.
Yeah, no, that was great. That was great. Okay, great. So we're actually about to finish on time. So I just wanted to make some closing remarks. You know, looking at these use cases you guys have come up with, I see a lot of overlap in kind of proof that something happened, or proof that you've applied for something, right? So with the DMV case, medical records, all that kind of hospital queuing, COVID queuing, vaccine queuing, all that kind of stuff. Even the RDP houses, right? It's proof that I was in this queue and now I'm not in this queue. Or, you know, I was number 5 and now I'm number 60, you know. So having kind of like from all these use cases, looking at it, it seems like there's the need for proof of history, right? What happened? What was the queue? What is the queue? Who changed it and why? So Meryl, I'm not sure if you'd like to come up and give some closing remarks as well, but I've really enjoyed giving this talk, and I hope it's been beneficial for you guys. And if you guys need any additional help with anything, you know, I'm always available, and I'm always very excited to kind of help with any government use cases. I'm really passionate about South Africa, and yeah, so feel free to reach out.
Thanks, Veronica, and thanks Linum Labs for running a fantastic 2 days. I think everyone has learned a lot. I mean, I've learned quite a bit as well from being present, because yeah, you excellent work. And I also wanted to just thank all the government representatives that actually did attend. I think a lot of them have left. They have other things that they need to do. And for coming up with such fantastic ideas. I would urge all of you to please try and join SANBA, so that you can keep updated with things that are happening. We will. You're welcome to contact me directly or through SANBA. There's a question here: can we get the link on the use case of SMS and blockchain integration? That was a thesis that was developed. So what I can do is I can try and get hold of that thesis. It was written about 5 years ago, believe it or not. So there's probably a lot that's happened since then, but I'm more than happy to share that thesis with you. And yeah, it just kind of thanks everyone who was involved with this. We will keep all of your contact details, and once we actually have decided on a use case, a proof of concept use case, we will let you know. You're welcome to contribute to that. You're welcome to be part of that. You're welcome to link us up to other people in government who should be involved in this use case. So We are very excited about kind of taking a government use case one step forward, where we can actually physically show what's possible with blockchain. Thanks so much. Bye, everyone.